Hello and welcome to the Stardog Academy training on .NET. This is Joseph Hayes, one of the senior software engineers at Stardog. To let you know a little bit more about me, I love helping customers maximize the value they can get from their data by implementing innovative solutions to complex data problems. In this training session, you will learn how to install dotNetRDF library, connect to Stardog and create a database using dotNetRDF, query Stardog using dotNetRDF, install the TrinityRDF object mapper library, connect to Stardog using TrinityRDF and create ontology mappings, query Stardog using TrinityRDF. Let's get started. This section is about introducing and installing dotNetRDF. .NET developers can use dotNetRDF as a client for Stardog, providing access to functions such as executing Sparkle queries, administrating Stardog, and the Inference API. dotNetRDF's implementation uses Stardog's HTTP API. For more information, go to the Stardog HTTP API documentation. In typical .NET environments, use NuGet to install dotNetRDF. To connect to a Stardog server so we can run administrative commands against it, we create an instance of dotNetRDF's vds.rdf.storage.management.stardog server class. The Stardog server class constructor takes a Stardog server URL and a user's username and password as parameters. It can also take proxy information if a proxy server is required to connect to the Stardog server. With a valid instance of the Stardog server class, we can perform the following functions: list stores, get a list of databases defined on the server; delete store, delete a database; create store, create a database using a template. dotNetRDF allows you to create databases using a template. The template defines various database options which will be used when creating the store. To work with graphs in a Stardog database, we need to create an instance of the vds.rdf.storage.stardog connector class. The Stardog connector class constructor takes a Stardog server URL, database name, and a user's username and password as parameters. It can also take proxy information if a proxy server is required to connect to the Stardog server. With a valid instance of the Stardog server class, we can perform the following functions: update graph, add or remove triples, save graph, save a graph to the database, query, run a Sparkle query. We can run a reasoning query by simply setting the reasoning parameter to true, and list graphs, list the graphs in the database. Note that all of these functions are provided as both synchronous and asynchronous versions for maximum flexibility when developing a solution. This is the demo about .NET. In Visual Studio, or in any typical .NET environment, we can use the NuGet package manager to install dotNetRDF. We simply invoke the package, manage packages dialog, and then search for dotNetRDF. Select the package, and then add it to our solution. This concludes the section on .NET. This section is about using dotNetRDF to connect to and create databases. Let's look at some examples. When we create a connection, we provide two examples, one for connecting using the Stardog server class and one for connecting using the Stardog connector class. For the Stardog server class, we provide the server URL, a user's username and password to the Stardog server class constructor. For the connector, we provide the Stardog server URL, the database name, and a user's username and password. To create a database, we call the getDefaultTemplate method of the Stardog server class, passing it the name of the database we want to create, and then we pass that template to the createStore method. To drop an existing database, we call the deleteStore method, passing it the name of the database we want to delete. In this example, we want to check if a database called MyDB exists. If it does, drop it. Then we create a new database with the same name and the default settings. To check if a database exists, we call listStores, which returns an array of the database names. We then check to see if it contains one called MyDB. If it does, we use deleteStore to delete the database. We then get the default template from the server, passing it the name MyDB, and pass that template to the createStore method. To add data, we have to call the updateGraph method. In this example, we create a triple using the triple class, and then we pass it to the updateGraph method of the Stardog connector class. Please note that if the user does not have permissions to actually write to the database, the code will throw a vds.rdf.storage.rdf storage exception, which will wrap the HTTP 403 error returned by the Stardog server. In this example, we load a file into the database using an instance of dotNetRDF's Stardog connector. We create an instance of the graph class, and we call its loadFromFile method to load a file into it. We then set the base URI of the graph instance using the base URI property. Finally, we pass the instance of the graph class to the saveGraph method of the Stardog connector. This will write the graph back to the database. Note that if the user does not have permission to write to the database, the above code will throw a vds.rdf.storage.rdf storage exception, which will wrap the HTTP 400 error returned by Stardog. This is the demo about using dotNetRDF to connect and create databases. In the sample code provided, there is an example of how to connect to Stardog using dotNetRDF and how to use it to list databases, create databases, and delete databases, as well as add or remove data from those databases. In the code, you find that we create an instance of the Stardog server, passing it the server URL and a Stardog user's username and password. Note, by using the using keyword, we can automatically call dispose and clean up any resources we use for the Stardog server class. Once we have a valid instance of the Stardog server class, we can check if our database exists by calling the list stores method. If it does, we can call delete store to delete the database, and then we can create it using a template using the create store. Once our database exists, we can use the Stardog connector class to add or remove triples and data from that database. In our first example, we create a triple and we use the update graph method to add it to our database. We could also load data from a file using the load from file method of the graph class and save that to our database using the save graph. This concludes the section on using dotNetRDF to connect to and create databases. This section is about querying Stardog using dotNetRDF. In this example, we query the database by running a Sparkle query. Reasoning is off by default. To run a query using dotNetRDF, we use an instance of the Stardog connector class. Please note that reasoning is off by default because reasoning can have an impact on query performance. So it is better for the user to make an explicit decision to use reasoning when running a query. In this example, we query the database by running a Sparkle query, and reasoning is turned on. Note that we turn on reasoning by passing true as the second argument of the query method. This is the demo about querying Stardog using dotNetRDF. Once we have a valid instance of the Stardog connector class, we can use its query method to send Sparkle queries to the Stardog server. This will return an instance of the Sparkle result set to us, which contain the results of our query. We can then process these results as we want. I'm now going to run this code. Please note there's additional debugging statements inserted so we can see the output and the calls as they progress. Okay. When we look in the what has been returned and printed out to the screen, we can see the results of our query right there. This concludes the section on querying Stardog using dotNetRDF. This section is about TrinityRDF. Please note that the slides in this section assume there is a database called Music on your Stardog server, and it is loaded with the schema and data from the links that accompany this training. .NET developers who want an experience similar to Entity Framework can use TrinityRDF to interact with the Stardog server. A big advantage to using TrinityRDF is being able to use LINQ to query the database. Note that TrinityRDF is built on top of dotNetRDF. In typical .NET environments, use NuGet to install semiodesk.trinity. This is the demo about installing TrinityRDF Object Mapper Library. With a new solution, we can use the NuGet Package Manager to install TrinityRDF to our project. In Visual Studio, invoke the Manage NuGet Packages dialog. Search for the package we want, semiodesk.trinity. Select it, and then add the package. This adds the package to our solution and our project. Make sure to click Accept on the License Acceptance dialog. This concludes the section on installing TrinityRDF Object Mapper Library. This section is about connecting TrinityRDF and ontology mapping. To connect to Stardog using TrinityRDF, we have to pass a connection string to the Stardog Store Provider class. This class is provided as semiodesk.trinity.store.stardog store provider by TrinityRDF itself. Once we create our connection string, which defines the name of the provider, the server URL, the user's username and password, and database name, we can pass it to the store factory create store method, which will establish the connection to the Stardog server. We have to make TrinityRDF aware of our ontologies, so we can use a special XML configuration file called ontologies.config. This file specifies namespace, prefix, and file source for each ontology. We can use the ontologies config file to initialize our Stardog connection via the initialize from configuration method of our store's instance. TrinityRDF reads the ontologies config file and uses it to generate annotations which we can use to create object model classes that map to RDF classes. In this example, note the annotations RDF class music.band on the band class definition and RDF property music.member on the members property definition, which were generated by TrinityRDF. The annotations are generated in a pre-build step performed by TrinityRDF. The generated code can be found in a file called ontologies.g.cs. This is the demo about connecting TrinityRDF and ontology mapping. In TrinityRDF, we connect to Stardog using the Stardog Store Provider. We do so by passing the createStore method a connection string, which will define our provider name, our server URL, our credentials information, and our database name. Once we have a valid connection, we can begin the process of making sure that TrinityRDF knows about our ontologies and can generate the mappings from our ontologies to our C# object classes. The first steps we have to do are on 41 and 42, lines 41 and 42, and that is called ontology discovery at assembly, and we pass it the currently running assembly. The second thing we do is called mapping discovery .register calling assembly, and then we initialize our store instance on line 61 using our ontologies config file. Let's talk about this file a little bit. Our assembly is going to contain pointers to various ontologies. These need to be listed on ontologies.config. This will contain the URI, the prefix, and the file source location of each ontology we want to use in our code. When we pass these to TrinityRDF via the initialize from configuration call, this invokes a pre-build step which will generate a file called ontologies.g.cs. This will create and contain the various annotations we will use in our classes to map from our object files back to our ontologies. So let's take a look at an example. Here we are. This is one of our mapping classes. This is album.cs. So this is supposed to represent record albums that are defined in our ontology. Notice the annotation RDF class pointing to music.album and RDF property pointing to music.name. Now these mean that this plain old C# class, POCO class, points back to both the album class here in our ontology and the name property in our ontology. And this is done via using these annotations that are generated for us in ontologies.g.cs by TrinityRDF. So to recap, in order to have TrinityRDF generate the annotations we need to create mapping classes, we have to tell it about any ontologies we want to use in our ontologies config file. We then use that file to initialize our store using the initialize from configuration method. And before we do that, we also need to register our assembly with ontology discovery and mapping discovery classes. This concludes the section on connecting TrinityRDF and ontology mapping. In this section, we query Stardog using TrinityRDF. One of the big advantages of using TrinityRDF is being able to use LINQ to query data. A developer no longer needs to learn Sparkle to use Stardog. In the following example, we use LINQ to find all the bands that start with the string The Beatles. We then use the bands we found, we take the first one, and we then query all of the albums that this artist has produced, and we display a count back to the user. Note that this is all done using LINQ. No Sparkle was used. TrinityRDF handles generating that for us under the covers. LINQ also allows us to aggregate data. In this example, we find the album, we select a random album of the artist from the previous example, and then we total up the length of the various tracks on that album and display it to the user. We can even use reasoning queries by passing true to TrinityRDF's as queryable. In the following example, our ontology defines artist as the base class of both solo artist and band. If we run this query without reasoning, it returns no records. But if we turn reasoning on, we then get results as solo artist and band are both subclasses of artist. This is the demo about querying Stardog using TrinityRDF. Once we've created our connection to Stardog using the provider class, and we have also created our mappings using ontologies.config, we can then use those to issue queries to Stardog. The first thing we have to do is call the getModel method on our store instance. We can pass it a URI so we can interact with one of the named graphs within our database. We can utilize link to query Stardog by using the asQueryable method of the model. Simply, we call asQueryable, pass it the class we want to interact with, and then any parameters we need. If we pass true, we can issue reasoning queries. If we pass false, which is the default, then the queries are executed with no reasoning. We can also use other link functions like order by and toList to manipulate the results returned from the asQueryable call. Notice or note that the queries are not actually issued until you start to use the result. So asQueryable and whatever query you give it is evaluated in a lazy fashion, right? So here we're looping through all the bands and printing out their members. Now you can use TrinityRDF to also issue normal Sparkle queries. And here's an example of that. Using model, we can also send a Sparkle query directly to Stardog, right, and interact with the results. But much more powerful, of course, and the whole reason you want to leverage TrinityRDF is because you don't have to use Sparkle. You can instead use Link and interact with the data contained in Stardog in a way that's much more familiar to .NET developers. So here is the same query just about, looking at all the instances of the band class, right, where the band name starts with search string. In our case, search string, you'll notice there in the little pop-up, is defined as the Beatles. So once we have our band, our man that match, we print out the members, we look at the various albums, we can pick one of the albums at random here in line 207, and then we can print out the information about the tracks. Now normally this would require us to do several steps to provide, the links between these various items that we want to query. But notice we're just doing it through the normal connections and that are provided by the mappings that we created previously. So when I run this code, we're going to see that it prints out all of the bands and then finally does a search and finds the Beatles, selects one of their albums, right? And prints out all of the tracks on that album. So it printed out for the Abbey Road album, all the tracks here. This concludes the video on querying Stardog using TrinityRDF. That concludes the Stardog Academy training on .NET, using .NET to access and use Stardog Server, where we reviewed how to install dotNetRDF library, connect to Stardog and create a database using dotNetRDF, query Stardog using dotNetRDF, Install the TrinityRDF Object Mapper library. Connect to Stardog using TrinityRDF and create ontology mappings. Query Stardog using TrinityRDF. Thanks for following along. If you have any questions, please review our frequently asked question page or head to stardog.com/docs for additional information.